to a Math Warehouse video on how to solve systems of linear equations with three variables. By the end of this tutorial, you should be able to look at something like this and know how to use elimination to find the solution. Okay, so this tutorial is broken down as follows. We're going to go over a quick overview of solutions and what these systems are, how to use the elimination method. Number 2 is the bulk of the tutorial, and then I'm going to show you a really cool free online tool that would let you type in your equations and give you the solutions. Okay, so this is the second video in this series that you can find at mathwarehouse.com/planes. The first one went over in detail what a system of three variable equations is, what they look like, and what they are. Quickly to recap, a system of linear equations in three variables is a system of planes. When we have an equation with three variables, an x and y and a z, it ends up being a plane. Two variables gives you a line. Three variables is a three-dimensional object, which is a plane. For instance, this purple plane, this black or this green plane. And in the last tutorial, we looked at pictures and came to the following conclusion. If you have three planes, you can either have them never meet, like these are three parallel planes. You can have them meet at exactly one point, like the middle picture, or you can have an infinite number of solutions where you see this red line is the line of intersection of these three planes. And in general, whether planes intersect or not determines whether they are consistent. So sorry, I had to fix my pen. So a plane is consistent a system of planes is consistent if they ever have one point in common. This black point is consistent with all three planes. It's on the green plane, the purple plane, and the red plane. This red line is full of points that are consistent. So these two pictures represent a consistent system. On the other hand, this is an inconsistent system because there is no point that is consistent or true for each plane. Now, just quick vocab reminder, when we say a line or a linear equation with three variables, that's the same as a plane. So I might say a linear equation with three variables, or I might say plane. They mean the same. Our goal today is to find out whether systems are consistent, and if they do have one solution, to find that actual point. Now, before we move on, it's important that you understand what the elimination method is. So I'm going to review what elimination is for linear equations with two variables. In other words, for a system of lines. Before doing this topic on three-variable linear equations, you definitely should have seen equations like this. This is just a line, and that's a line, and we want to find their point of intersection. Now, there's lots of ways to do it. You can solve for y and substitute that in for the y in the other equation, or you can use elimination. The idea with elimination is we're going to look at a variable to get rid of. We're going to either target the x or the y and do something to our equations so when we add them together, remember you can add equations, so that when we add them together, one of the variables is eliminated. Let's say we want to eliminate the variable x. What we can do is we can multiply the entire top equation by 32 and the entire bottom equation by 10, and these equations become 320x plus, and you do need a little calculator, you need to do it in your head, 32 times 12, which is 384. 384y equals 32 times 52. Put that in your calculator and you get 1,664. Okay, it doesn't look like we've made any progress, right? It looks like, but when we multiply the 10 by the bottom equation, you'll see how we can eliminate the. So 10 times 32x is going to give us 320x. You probably see now that x is our target. We're going to get rid of that. 200y equals 560. Okay, so now we have two equations. And you can add or subtract equations. And in our case, we want to subtract the bottom equation from the top. because 320x minus 320x gives us the 0 that we wanted. 384y minus 200y is 184y. And lastly, 1664 minus 56 gives us 1104. Alright, so now we're in great shape because we have one variable, y, which I'm brutalizing here. Sorry, this is 184y equals 1104. And now we just have to divide both sides by 184. And we can know the value of y, which is 6. Now that we know that y is 6, we can find out what x is by just substituting that into either equation. So we have 10x plus, I'm going to use this equation here, 12 times y, which is 6, equals 520, equals 52. So 10x plus 72 equals 52. Subtract 72 from both sides, right, and you have 10x equals negative 20. Divide 10 by both sides, and x equals negative 2. Okay, so just a quick recap. To do elimination, you target one variable. I targeted the x, and you can manipulate the equation however you want. Multiply. Usually you multiply by numbers so that you end up with the same coefficient. Then add or subtract to get rid of it. Once you have the one variable, you substitute it in to get the second variable. Now, this is going to be a small part of a future of the next problem that we're going to do, and we're going to use a very similar method to do this new topic. The new topic of a three-variable system of linear equations. So our goal is going to be, let's eliminate a variable. Now, you can choose any variable you want to eliminate, but I immediately noticed that we have a 4z and a negative 4z. So it's actually going to be pretty easy to do those two equations as one of our and you'll see in a minute what I mean by one of our eliminations. So let's just focus on what's pretty intuitive at first, that this 4z and this negative 4z is just begging to be eliminated. So we're going to take these two and put them over here. So we have 2x plus 8y plus 4z equals 32. Then we have 30x plus 12y minus 4z equals 24. Now remember, we can, like we said in the last review there of two variable systems, we can add or subtract equations together. In this case, we just need to add because these are already going to knock each other out. So we're going to add, and we'll end up with 32x plus 20y, 4z minus 4z is 0, equals 32 plus 24, or 56. So we eliminated a z here. Now the problem is, we still have one equation, right? This is one equation, and with two variables, an x and a y. So you can't solve that. You cannot find, there are so many x and y values that are going to work for this. We cannot solve one equation with two variables. We need a second equation with two variables. So let's think about it. We never use this equation here. So if we compare this equation with one of these other ones and do the same thing again, eliminate a z, we'll end up with a second equation, but different one over here with x's and y's. Then it's like the good old days of the review problem we just did, where we have two equations, two variables, x and y, and we can solve. Okay, so I'm going to pair a and b together. You could have gone a and c, but I'm noticing that again, we're targeting z. We're trying to get rid of z by reproducing what we did before. We've got equation a, 4x plus 2y minus 2z equals 10. And I'm going to pair it with this guy here, equation b, which is 2x plus 8y plus 4z equals 32. Again, this second equation here, we could have used C, but the reason I'm going for B is because I'm noticing there's a negative and a positive in front of the Z's, and I'm trying to knock out a Z. That'll be a little more obvious in a minute. To be able to do that, though, let's multiply the top by 2, which will make our Z nicer. So this equation here becomes 2 times 4, 8x, 2 times 2, plus 4y, minus 4z, that's what we wanted, equals 20. Okay, so now our z's are going to go away, and we're going to end up with 10x plus 12y. Z's go away, and this equals 52. Now notice, we are in a very nice place now, and a place you should be familiar with. We've got two equations. We can call this equation E and equation F. These are two equations with two unknown x's and y's, and it's just now, all we have to do is solve a system of lines, basically. In fact, this is the very system that we just solved in our review. I'll go back to that. Alright, look, 10x plus 12y equals 52, 32x, 32x plus 20y equals 56, equation E. Right, that was what we reviewed. And we found out that x equaled negative 2, y equals 6. So what we did, let's recap what we did so you didn't miss anything. We have three equations with three variables. We know how to solve two equations with two variables. Right, it's just like this. We did it as a review. So what we're going to do is we are going to target one variable to eliminate, and we're going to come up with two pairs. I paired them as A and B on the left, and then B and C on the right. And for these two pairs, there's going to be one variable we'll knock out. We knocked out the Z. We targeted Z. You could target any variable you want, but you've got to get rid of the same variable from both pairs. Because then what you end up with is something you should be familiar with. Two different equations with two different variables, and we know how to solve that, which we did in our review. We used elimination to find out that x equals negative 2 and y equals 6. Okay, so we found from our prior work that x equals negative 2, y equals 6. This system here, all we need to figure out now is what is z. And we can take negative 2 and 6 and put them into any equation that we want here to figure that out. So let's try equation A. We can say for equation A, just punch it in there, 4 times negative 2 plus 2 times 6 minus 2z equals 10, right? Negative 8 plus 12 equals negative 2, sorry, should be minus 2z equals 10. Okay. I filled in some of the work just to get it out quickly. So simplify this and you get negative 8 plus 12 is 4, minus 2z equals 10. Subtract 4 from both sides, you end up with negative 2z equals 6. And when you divide both sides by negative 2, you're going to get z equals negative 3. And that is our solution. Our solution is x equals negative 2, y equals 6, z equals negative 3. Okay, this is the elimination method. Let's try the same idea with another problem. Let's solve this system. 3 variables, 3 equations. Remember, we need to first off break it up into 2 pairs. And before that, before we choose our pairs, we should think about what looks like an easy variable to pick off or to eliminate. I'm noticing that all of these z's have the same coefficient, and that's usually a good way to choose z. A good reason to choose. And you don't have to choose z. Actually, if you go to our website, you'll see this same problem with and we use a different variable to eliminate first. But we're gonna do the top 2 Okay, I picked my target variable to eliminate, z. I broke it up into two pairs. Now I just have to decide whether I should add or subtract. Let's subtract, right? Because we have positive z, and we want the z's to cancel out. So this is going to actually work out very nicely. X minus x is 0. Negative y minus y is negative 2y. Z minus z is 0. Negative 1, this becomes negative 3, is negative 4. This is really great. This not only knocked out z, but it also knocked out y, and lets us immediately solve for y. Y is going to be 2. What about over here? Over here, let's see, we should do the same thing. We should subtract. Okay. So x minus 4x is negative 3x. Y minus 2y is negative y. Z minus z is 0. 3 minus 8 is negative 5. Alright, so this was particularly fortuitous because normally when you pair your equations and solve, you end up with what we have on the right side. You end up with, or on the first problem that we did, you end up with an x and y, an x and a line on the right, an xy equation, and another one of the same type on the left. However, here we managed to also eliminate our x. We already know part of our solution, y is 2. Why is this so awesome? Because we don't need to solve the system of lines. If you remember what we did here we had an x and a y, and here we immediately know what y is, so maybe you can already figure out what we're going to do. We're just going to take y equals 2, throw it in there, and we'll end up with negative 3x minus 2 equals negative 5. Negative 3x equals plus 2 minus 3x equals 1 when you divide both sides by 3. So now we know what our y is, we know what our x is, all we need is our z, and you can choose any of these equations up there and punch them in. I like the second one, it's all pluses, that's my style. So we got x plus y plus z, equation 2 equals 3. We know what y is, we know what x is, right? X is 1. Let me scroll down a little bit. So it's 1 plus 2 plus, this is a z, equals 3. 3 plus z equals 3, z equals 0. So our solution is the point x equals 1, y equals 2, and z equals 0. Now, this is a long video. I'm not even done yet, but I just want to point out that one way that you can verify that you're right is you can take these values for x, y, and z, and it should work for all three equations. It's just like when you learn lines. This equation and the prior equation represented consistent consistent systems, because we found a consistency. In our case, the point x equals 1, y equals 2, z equals 0. That point is consistent with all three of our equations. Okay, let's look at one last example, and then we'll look at a really cool free online tool that actually does this for you. Let's look at this system here. Remember, first job is to choose a variable that you're going to target to eliminate. And none of them seem really all that great because we got different coefficients, 2, 1, 4, 2, 1, 2, 2, 1, 1, which means we're going to have to multiply by something no matter what. I'm going to target y. I'm going to try to get rid of the y. I'm going to group them A, B, and B, C. So we're going to put A, B here. We're going to put B, Z, B, C here. Okay, so if I'm going to target y, I need to get, the same coefficient in front. So I'm going to multiply on the left side by everything by negative 2. Alright, so let me rewrite these. So it's going to be 2x plus 2y plus 2z equals negative 4. And on the bottom, it's going to be negative 2x minus 2y minus 2z equals negative 6. Right, So I just multiplied by negative 2, wrote that here. Rewrote this equation here. So here's the pairing. And what are we going to do next? If we're going to get rid of the y, though z is looking tempting here, but we're going to get rid of the y, we just want to add it, right? Because we've got 2y minus 2y. So 2y minus 2x is 0. 2y minus 2y is 0. 2z minus 2z, whoa, is 0, equals negative 10. Now that is a problem. We just took our equations, and all we did was multiply them and add them, doing our totally valid stuff with rules of algebra. We ended up with 0 equals negative 10. Any idea what that means? The good news is it means we don't need to do any more work, because we already know that there's no way to solve this system. This system is inconsistent. It has no solution, because you would have to have a solution in a world where 0 equals negative 10. We know that doesn't work. Okay, so this turned out to be a very easy problem. It was inconsistent because we ended up with 0 equals negative 10. Alright, I promised you at the end I'd show you a great tool that lets you type in equations like this and find the solution. Okay, the tool is called Meta Calculator. You just go to www.meta-calculator.com, and it says lots of cool things, like a graphing calculator that can graph pretty much any equation you could think of, even funky things like sine of x equals y. But we're not interested in the cool graphing calculator. We're interested in the scientific calculator equation solver. Now in here you can solve systems of lines or systems of 3 variable equations like we've been doing today. So I just loaded up 3 equations that we looked at earlier, x minus y equals plus z equals 1, and boom, the solution is what we found before. Okay, so you can put anything that you want in here. If you wanted to work with systems of lines, like back when you were in the good old easy days, it could also find solutions like that. But the main value here for us in this lesson is you can enter systems of 3 variable equations and it'll find the solution for you if you want to double check your work on this. Again, that's meta-calculator.com. Okay, thanks a lot. That's it for solving systems of 3 variable linear equations using elimination. Check out mathwarehouse.com/planes if you want to find out some more. Thank you.